In this problem, we're going to do much the same as the last problem, except we do have a couple more things that we're going to add to this. So in this one here, we need to solve for the unknown side x here. So we've been given two sides of a right triangle, which means that we can use Pythagoras to find the third side. Okay, so anytime we have two sides of a right triangle, we can always use Pythagoras to find the third side. The other thing that we're going to do is I'm going to get you to name the ratios. Instead of just talk about the ratios, we're actually going to write them down. Okay, so in this case here, we're going to use the opposite of angle A. So that's going to be this side here. That's why we have to solve for x. And we're going to use specifically adjacent to angle A. Okay, so the side next to angle A is going to be this one here. This one's always a hypotenuse. Hypotenuse is always hypotenuse. So first things first, we're going to solve for side x. So we're going to use Pythagoras. And since it's a shorter side, we need to subtract because this square plus this square does not equal this square. We would not add these two squares together to get the area of this square here. However, we can take the area of this big square from side 13 and subtract the area from the side 12 square to get the area of the side x square. So that's what we'll do. So we end up with x squared. This square off of this side is equal to the big square minus the medium square. Okay, in doing so, we get 169 minus 144. So the x square is going to be a 25 square. So finding the side length, we square root. We get plus minus. We don't need the minus. And we know that x then must be a length of 5 because the area is 25. Okay, so that's the first part. Now we're going to use specifically the opposite of angle A. Okay, so the opposite of angle A, and compare that to the same triangle side of adjacent to angle A. Okay, so we're going to do 5, and then in the same triangle, we're going to compare it to the adjacent to side A, which is 12. Okay, so now this ratio we can use as, we can write a decimal ratio for this, but we're going to keep it as a fraction because it'll be easier to solve as a fraction. But once we make this comparison, this side to this side, we're going to make an equivalent comparison within this triangle here. So we're going to use opposite of angle A to adjacent to angle A. Okay, so it's going to be side length 1, and the adjacent to side A is going to be B, so we're going to get B here. So here we can see that there is a times 5 multiplier here, so we can divide by 5. So 12 divided by 5 is 2.4, so we get B is going to be 2.4. So we can solve it this way. We can remember this is a proportional equation, so this is times divide relationship. If I divide these, I get my unit rate, okay, which is going to be my decimal ratio. Or in this case here, I'm just going to solve this algebraically and cross multiply. So I get 5 times B is equal to 12 times 1. Solving for B, I get 12 divided by 5, and there's our 2.4 showing up. Okay, so this length here is going to be 2.4 units. So I could solve for side C by using Pythagoras here, but it's going to be much easier to use a ratio comparison. So for the next one here, you can use whatever side we want. So we want to solve for side C, so we're going to have to involve the hypotenuse in our ratio. And I can compare it to either the x, which is 5, or which is the opposite of angle A, or I can compare it to the adjacent to angle A. It doesn't really matter because I have the same comparisons in this triangle here as well. So I'm going to just arbitrarily, just randomly select adjacent. So I'm going to compare it to the adjacent angle A, which is going to be side 12. 12 to the hypotenuse, adjacent angle A to the hypotenuse of angle A, 12 to 13. And the same comparison is going to be made over here. I'm going to compare side B, okay, adjacent to angle A to the hypotenuse of angle A. So it's going to be 2.4 to side C. Okay, so I have the same comparison in both triangles. So at this point I have just one variable to solve for. I can see that this is going to be divide by 5 here. It's hard to see, but that's going to be divide by 5. So I can divide by 5, okay, to solve for that. Okay, I could also cross multiply and solve it algebraically. So I'm going to do that. So 12c is equal to 13 times 2.4. So using my calculator, if I use 13 times 2.4, find my calculator here, 13 times 2.4, okay, that's going to be 31.2, and I'll solve for c by dividing both sides by 12. Okay, so 31.4 divided by, 31.2 divided by 12 equals 2.6. Okay, and that's the same as I would have gotten if I had used that divide by 5 that I recognized in this proportion. Okay, but again, if you don't recognize it, no big deal. We can always always have some other strategy that we can use. So that side length is going to be 2.6.